Okay, so question number 4. What are the Lewis structures that can be drawn with the compound formula C2H4O? So first let's count out how many valence electrons we should have in this molecule. So for the total number of valence electrons, carbon contains 4. And there's 2 carbon atoms, so let's multiply them by 2. Hydrogen has 1, and this will be multiplied by 4. And oxygen just contains 6. So this gives us a total of 18 valence electrons. So now let's try to write out some plausible structures for this formula. So we know that when we have just carbon, carbon, and then single bonds to the hydrogens, we know that we need to draw a double bond in there somewhere. So let me just show how if we were to draw our 4 or 3 hydrogens and an oxygen, then both of the carbons don't have a full octet, so they only both are attached, or they both only have 3 bonds attached to them. So if we draw a double bond, and if we show the lone pairs on the oxygen and count out how many electrons we have, each bond contains 2 bonding electrons, plus the 4 on the lone pairs on oxygen. This gives us our 18. So this can be a valid Lewis structure for compound with C2H4O. And we can also kind of experiment and draw out if a carbon was double bonded to an oxygen, and then draw out all the different hydrogens. Again, having the lone pair on the oxygen, this also gives us 18 valence electrons with the same formula. And then lastly, we could have kind of like an epoxide where the oxygen is singly bonded to 2 carbons, and then each of the carbons has 2 hydrogens. So this can also give 18 electrons with the same compound formula. And if we see what the junior tutor said, they said the same 3 structures. So this solution is correct.